Software packages are the secret ingredient on most of your favorite apps. Almost every software developer uses some kind of dependencies to extend or accelerate the development process. GitHub Packages provide a place to share and manage all your packages centralized in the same service. In this course, we learn how to create, manage, and distribute software packages. In addition, we will explore how to work with GitHub tools, create automated workflows, and even tips and tricks to monetize and build communities around your software package. Hello, I'm Carlos Solis, author and web developer for almost 20 years, and I will walk you through everything you need to get started with GitHub Packages by using best practices, advanced workflows, and managing all your packages and dependencies in just one place. This course will focus on creating packages and making the most of the GitHub platform. The first thing you need to have is a GitHub account. If you don't have one, go to github.com and create your account right now. During this course, we're going to create a package example using the npm format. If you're not familiar with the node package model, go to docs.npm.js.com where you can find information about the format. Also, make sure that you have Node.js installed. You can find it on nodejs.org. We're also going to integrate GitHub tools to create automated pipelines for packages, and some services work with YAML, a simple markup language very popular to configure software. If you're not familiar with YAML, visit yaml.org and spend a couple of minutes learning the syntax. It's simple, powerful, and will become handy when we start working with GitHub Actions. You're gonna need a code editor to modify package files. In this course, I'll use Visual Studio Code since the terminal is integrated, but you're free to use your editor of choice. If you don't have Git in your system, the installer is located on git-scm.com. During this course, we're going to use it in many lessons. Finally, if the system terminal is not your cup of tea, feel free to install a Git client such as GitHub Desktop to install Git interactions. You can find it on desktop.github.com. Once all this software is installed on your system, you're ready to start creating your GitHub packages. Let's start this course by asking, what are GitHub packages? In a nutshell, GitHub Packages is a software hosting service that allows you to host software packages. Once your package is hosted on GitHub, authorized users can download and install your packages using the GitHub registry. GitHub Packages support multiple platforms and programming languages like Docker, Gradle, Maven, NPM, Nugget, and Ruby Gems. You can publish packages in all these platforms and even host them in the same repo, sharing common dependencies. Hosting packages on GitHub provides a centralized place to manage all your packages, code, and dependencies in the same service, reducing complexity and making it easier for developer teams to collaborate. GitHub uses its content delivery network to distribute packages, which means your users will have faster, reliable, and efficient downloads. Keeping all your packages in the same place also means easier and safer management of packages and dependencies. You can integrate GitHub Packages with GitHub APIs, Actions, and webhooks to create complex workflows to test and deploy solutions. Package owners have complete access control, and GitHub supports private and public packages. This covers many different scenarios, from massive open source projects to small private projects with sensitive code only available for a few developers. Large organizations can benefit by using group permissions for the users. Finally, package developers can use GitHub social tools such as issues, projects, and pull requests, where developers can collaborate and plan future improvements. GitHub offers an end-to-end solution to share, manage, and develop software packages. In this lesson, I'll show you how to create a Node.js model. This is going to be the code base for a GitHub package. Here I'm working in Visual Studio Code and I'm going to open the terminal using View, Terminal, and first I'm going to create a folder called My Package. Here's where I'm going to write the new model. Every package is, in a nutshell, pre-made code ready to be used in other applications. This code needs an entry point, a file that initializes the model and contains its main methods. In this case, I will create a file called index.js that runs every time this model is invoked. You can use different formats and approaches to compose a model. For example, I like to use a class to keep my methods and properties in the same scope. Also, the constructor method is always handy. To create it, write class, and its name, in this case, I'm going to use user. Now, let's add a constructor. This block will run as soon as the class is invoked before any other method. So let's include a small property here and a console message. We can also include methods such as get username or get user status. And we can use this later. Let's wrap this class as a node model. To do so, include at the end of the code model.exports and the name of the class, in this case, user. Since this is a node model, we need to include a package.json file. To do so, let's go to the terminal, select the folder where the index.js file is located, in this case, my package. Now run the command npm init. The terminal will ask me for some information to create my package. By default, the package is the directory name. I'm going to click through to use this. Now by default, the version is 1.0.0, and we can keep this version, so press enter again. Include a brief description. And the entry point, the file that is loaded first when this model is used, in this case will be index.js. That is correct and already contains the user class I just made. So press enter and we can leave these fields blank by now. The last prompt is the license. In this case, I just keep the default value. Then we'll ask me if the provided information is okay, and by pressing enter, the package.json file is created. And that's it. If you follow my steps, mission accomplished. You just created a Node.js model. GitHub Packages include an additional security layer to control access to your software. In this lesson, I'll show you how to set up your GitHub access token. First, you need to log in and find your user menu in the upper right corner. Find settings and select developer settings. Click on personal access token and select generate new token. Now let's talk about permissions. For a regular user that just wants to download and use software packages, read permissions is all you need. For example, you just need to find packages and click on read. In this case, I need something different. I want to generate a package creator token. So I want to assign full permissions to modify packages. To do so, make sure to enable permissions to write, read, and delete packages. Once you have defined your permissions, click on Generate Token. Make sure that you assign a name for this token, for example, admin token. So I remember that this token have special permissions. Once again, click on Generate Token. And now you have a text string. That's your token. You must copy this and use it in your code to access GitHub Packages. Let me give you a couple of tips for your tokens. Tokens are hidden. This is the only moment you can see it. So remember to copy and save it in a safe place. There is no way to retrieve your token after this point. But if you're like me and tend to forget where you save your token, don't worry, it's possible to regenerate tokens. For example, I want to refresh here, and now the token is hidden. So if I want to regenerate, I just click on my token, select Regenerate Token, and a new token will be available to use. Just keep in mind this process requires updating any piece of software using the previous token. And this is how you create and manage access tokens on GitHub. Every GitHub package needs a GitHub repo first. So let's create one. Go to github.com and make sure you're logged in and select New. That will create a new repository. So let's select a repository name. In this case, my package repo. I want to keep that repo public, so make sure that I have selected the public option and click on Create Repository. Now here I have the instructions to upload my code to this repository. So let's move on to the code where I have my package. Here I have a package based on Node.js format. So before I send that to GitHub, I need to run one command to generate the package log file. This file is important in order to automate the process. So to create it, I need to run the command npm I, and this will create the package log file. Now that I have it, it's time to initialize this repo. So I need to run the command git init, git add, and a point, and now git commit -m and a message, my first commit. Now git branch -m and select the branch where we want to upload this. In this case is main. And now we need to assign the remote address of our repo. So let's go back to GitHub. And we need to copy this address, which is the name of my repo, with the full URL pointing to GitHub. And we can link both using the command git remote add origin and include the address of your repo. Now we send all the changes using git push -u origin and the name of the branch, in this case main. Now all the code is now hosted on my new repo. Let's refresh. Now you have a GitHub repo ready to manage and deploy your packages. To deploy packages using GitHub, you need a special setup to authenticate your code on GitHub's registry. In this lesson, I'm going to show you how to do it. First, and most important part, you need to create an npm rc file. Let's name it .npm rc. This is a configuration file for npm packages. I like to use this format since it's a simple way to prevent errors and force my packages to always upload to GitHub's registry. The first line of this code requires your username and GitHub's registry address. Remember to replace this part with your own GitHub's username. The second line is to authenticate using the token. In this case, I just generated one token and included here, but remember to use your own token here. Let's save the changes, and we're done here. Let's move to the package.json file. Here we need to include two values. The first one is repository, where we need to include the address of the current repository. To get that address, let's go to GitHub, and here is my repository. You can find it clicking on code, selecting HTTPS, and copying that address. Let's go back to Visual Studio Code and include that value here. The next value we need to add is publish config. Inside that value, I'm going to include registry, and the value that we're going to use here is the same we use on the npm-rc file. Just copy the registry address and move it to here. Now we have a package that is properly configured. However, it's important to never commit this file since we're including a security token. So we need to include another file called .gitignore, and in this file I'm going to include *.npmrc. This way we prevent the npmrc file it's committed to our repo. So now we're ready to send that information just by including git add point git commit -m with a message. And finally, git push origin main. And now our package is ready to deploy. Software packages are one of the most common ways to share code. This lesson will show you how to manually publish a GitHub package based on JavaScript. Before you deploy a package, it's crucial to verify you have an access token with reading and write permissions, a GitHub repository, and your package configuration using that information. Here, in my case, I am using the .npmrc file with my username, the registry, and a token. Also, the package.json file have the repository and the registry pointing to github.com. To prevent conflicts and make sure the package keeps a unique name, you should update the package name including your GitHub username. Here in the name, I'm going to change the package name with at my username / the name of my package. Let's save this file. And now that everything is in place, the only command we need to run is npm publish, press enter, and this command by default publish a package on npm.js.org. But thanks to the npmrc file, we need no additional configuration to deploy this package directly on GitHub. We just finished deploying this package, but what happens if we include new features? Let's try adding to index.js a couple of methods and properties. Here I'm going to include a message and a username properties and use this with two new setters and getters. Now we have a different version of our code. If we try to use the npm publish command, here we have an error, because once a package is published, every update requires a version change. So let's go to package.json, find the version, and change the value. For example, here, I'm going to change it to 1.1.1, save it, and run again the publish command. Now our package is deployed and updated. And if we check the package repo, now there's a new section for packages here with basic instructions on how to download the latest version. Installing packages from GitHub is easy. First, in your repo, locate the packages section and select your package. Here, you can find basic installation instructions. As you can see, it's possible to install this package using the command line. So I'm gonna copy this line using this button. Here I'm using Visual Studio Code with a basic React app I just created. Let's run my package install command and see what happens. It shows an error because by default, this command searches for packages on npmjs.org. Let's enable the GitHub registry. We need to create a file called .npmrc. Here, we must include a username and a token. Here's my username, here's the token, and also the registry address from GitHub. Remember, in both cases, to update these values with yours. Let's save this file and run the install command again. Now my package is installed, and I'm gonna start this React app on the browser, running the command npm run start. This simple package I made is designed to run a console message as soon as it starts. Let's open the console by right-clicking and select the Inspect option. Click on Console, and so far we don't have any message. Now let's import my package. Let's go back to Visual Studio Code, select Source, app.js, and import. Let's call it my package from, and I'm gonna use my username and the name of my package. Now here inside the app function, I'm gonna include another line to initialize my class using a constant. Let's call it demo equals new my package. Let's save and see the results on the browser. As you can see, we have a hello world message, meaning that my class is properly installed and working. And this is how you install and configure packages using the GitHub registry. Creating a package means you need to share code with more developers. In this lesson, you will learn how to create a free web page for your package. The easiest way to include information from your users is by having a README file. I am working on a package here in Visual Studio Code. To create a file with basic install information, you just need to add a new file and name it readme.empty. I can include some information such as my package name and install instructions, for example. And now the repo have basic information available for my users. This is fine for most cases, but if you want to build a community around your project, write extensive documentation, or monetize your packages, GitHub Pages could help. This is a free service to host websites. To enable it, go to your repo, select Settings, and find Pages. Now choose a branch, in this case main. Now I will select Docs as my page source and click on Save. Now go back to Visual Studio Code. Create a folder called Docs, and inside this, create a file called index.md. Here I'm going to include details of my project like installation details or the name of my package. I can also use HTML tags to make it easier. And I want to include the code to install my package. Now let's save all the changes and go to terminal. And it's time to sync up the repo by running git add point get commit -m and include a message saying that you just include a new README file. And finally, call git push origin and the branch where my page will live, which is main. If we go back to GitHub, now we can see that a README file is displayed at the root of the project. And now, if we go to Settings, Pages, and click on the link that was provided for my website, now we can see that the GitHub page is available here. We can also include a custom domain following the instructions provided by GitHub. And this is how you create a free web page for your package using GitHub. In GitHub, packages inherit the access permissions from the parent repos. That means if someone has access to a repo, they will have access to its packages as well. However, GitHub repositories have different types of permissions. We're going to talk about them in this lesson. In GitHub, repositories can have three different types of visibility. They can be public, or freely accessible to anyone, private, where only authorized users have access, and organizations, with permissions and roles to create public and private repositories with different access tiers. When you distribute your package through a public repository, anyone can search on Google or GitHub, find your package, and install it. The code of this package is also public and visible to anyone. This is the default option on GitHub, and many projects are developed in public repositories. This type of repository fits very well for open source projects where you want more users to participate and share your code, creating an open environment. Repositories can also be private. Any public repository can modify its properties to become private. Private repositories have limited contributors. The repository owner must manually register them. Private repositories are perfect for personal or private projects where you want to limit the number of users or maintain privacy on your package's code. Finally, organizations can also manage repositories and packages. They can create public and private repositories, give access to its members based on groups and roles. And let me give you a tip. If an access token is used, always remember to authorize it within this organization. Only valid access tokens can access private organizations' repos. Organizations can also benefit by using GitHub Packages, since they can offer a wide range of options, from open source projects with thriving communities to internal packages reserved for just a handful of developers. Running tests on your package is crucial for consistent functionality and preventing errors in future code changes. In this lesson, I will show you how to run local and automated tests on GitHub. Here, I'm working with a simple package, and before I publish it, I want to set up tests to make sure everything works as expected. I like to use Jest for my unit testing on JavaScript, and to install it, just run npm I jest save dev. That will install Jest as a developer dependency. Next step, it's to include Jest as global in your computer. So run npm I jest -cli -g. That allow you to run Jest commands on any part of your system. So once you have that, you can run Jest tests on your computer. I already have created one here, and basically what I'm doing is to import my package and run a basic test. Before I can run my test, I want to update the package.json file. Find the scripts section and include the property test and the value jest. This way, every time you call the test command, it will run jest for every test you need. So let's test it. npm run test, press enter, and here I have my test that is passing. So now I want to replicate this workflow on my repo to run automated tests every time my code is updated. Let's go to GitHub, and here I have my package with its tests. So let's go to actions. In GitHub, actions are automated tasks we can run. So here, to create a new action, click on Setup a workflow yourself, and we're going to edit this file. First, change the name, for example, test action. Now we can set up the triggers. Triggers are the different events that will activate this action. Right now, we just need that every time someone push code to the main branch, this action will be executed. Keep this workflow dispatch, and here we have the jobs. Jobs are the different tasks that we can run on this action. So keep the build job that runs on Ubuntu. Keep the steps, the checkout, and here we remove this part. Now we need to run a couple of commands. In this action, we're working with a virtual computer, so we need to send a couple of commands. The first is run npm ci. That will install every dependency that we need for our code. And once we have it, we can run the npm run test. That will run the exact same test we just watched on my local computer. The next step is to press start commit. That will send a push to the main branch. So this way we start this action. Now let's go back to actions. And here we have the action we just created. Click on it. Here's the build job that we already have, and the tests for my package. This way, we can run automated tests every time a user updates the code. And now we had a GitHub action up and running. Choosing a software license for your package may seem like a trivial step, but it can make or break your project. In this lesson, we will talk about software licenses and how they can affect your packages. In a nutshell, open source licenses are legal and binding contracts between the author and the user of a software component. No matter which license you select, even if you choose none at all, the code of your package may restrict the rights to use, modify, and share your work without your explicit permission. The license you choose can affect how popular your software is with other developers and communities. In general, when a package has no explicit license, most organizations avoid using it to prevent potential legal risks. Knowing the proper license, scope, and effects on developers is crucial for software creators to start communities, find business partners, and sponsors for their projects. There are more than 200 different open source licenses. Each one states what users are permitted to do with your software and their obligations. Among the most popular and widely used, we have the GPL, the Apache license, the Berkeley license, and one of the most popular in modern open source projects, the MIT license. All of them are focused on different scenarios. Some are better for private projects, others for innovations or open source projects. At this point, you may be wondering, okay, licenses are important, but how to choose the right one? The first and most important answer is also the hardest. You need to read the contracts. Also, if you are part of a large company, it's possible that a license policy is already available. Ask your legal department before selecting a license for any package made for your organization. If your package has software dependencies, such as external libraries, read the license and ensure it's compatible with yours. In some cases, you may need to find alternatives to remain compliant. To help you choose the right license, GitHub made the Choose a License website. Here, you can find different situations for your community or project. Let me show you how to include the license on a new repository. When you create a new repository, here in GitHub, you have an option called Choose a License. If you click here, you can find the different licenses available for you. If you already have a package, make sure that you find the root folder of your package, in this case, the one that have the package.json file. Click on Add File, Create New File, and name the file license.md, and GitHub will recognize this name as a license and show the Choose a License template button. Click on it and select the license that fits your project. In this case, I'm going to use the MIT license. Here you can read the contract. You can review and submit the information. Commit the new file. And now we have a license file inside our package. Once you have that, let's go to the package section. You can see that a little legend saying that MIT license applies for this package. If you go back to the code and click on the license, GitHub displays a small brief for your users to know the conditions that apply to use your package. In all cases, you will have a license to display clear information for your users and how they can interact with your software. Removing packages is part of the life cycle of a product. In this lesson, I will show you how to publish, delete, and recover packages. Here, I'm working with a package, and I included a couple of changes. That means I need to update the version, and now I want to publish this new version of my package. We have different approaches to run this command. But in this case, I want to use it on my local computer. So just need to add the command npm publish and press enter. And now a new version of my package is available, in this case, in GitHub. But what happens if I want to remove it? For example, we have on npm a command called unpublish. But we have a problem if we use a GitHub package. If we press enter, you can see that we need to run the force command, and even if we run it, we're not able to remove packages using the command line. So let's go back to GitHub, and if we go to the packages section, select the package on your repo, and here on recent versions, you have all the versions that you already published for your package. Let's go to package settings. And if you want to remove a specific version, click on manage versions, select the version that you want to remove, for example, 1.1.3. You need to copy the name of your package, paste it here, and remove it. Keep in mind that users will no longer have access to this specific version. What happens if you want to remove the whole package? Just go to Options, click on Delete this package, confirm the name, and click on Delete. Now, on this repo, I no longer have my package published. That means any user that is working with my package will no longer be able to download it. If I want to restore that package, I need to go to Settings, find Packages, and here I have the package I just removed. Just click on Restore, confirm the name, and that will make my package available again on my repo. Now you know how to properly remove and restore your packages in GitHub. It's time for a challenge. Releases are stable versions of code that provide semantic versioning and context to users about the new features of your package. In this challenge, you need to create by yourself an automated pipeline to release your code. To solve this challenge, you need to work on two tasks. First, create a new release to share the latest features of your package. You can start the release process here in the release section by clicking on the Create a New Release button. The second task is to create a GitHub action. Here, you can publish the package on the GitHub registry, so users can start downloading and using the latest release. The whole process could take you about 15 to 20 minutes. You will apply what we learned about GitHub Actions, package publishing, and authentication. Before you start, let me give you an advice. Double-check the values of your package.json file and pay attention to how triggers and authentications work on GitHub Actions. If you need more information, check out the GitHub documentation. This process may take a couple of tricks. Don't feel bad if you get stuck at some point. It's okay. I'll show you all the details to make it work in the solution to this channel. In the meantime, have fun and see you in the next video. Let's start our solution to this challenge. The goal of this challenge is to automate the publishing process. To do so, we need to run a couple of steps. First, we need to update the package version. We need to store an access token to authenticate automation process. Create a GitHub action to publish packages, and finally, create a new release with automated publishing. Let's start with the package. Here, I'm working with a package, and if you notice, we're working on the 1.1.5 version. Before we can publish a new version, we need to update the version number. So let's go to code, find the package.json file, and modify the version. In this case, will be 1.1.6. It's important that every time you include new changes on your package, modify the version number. This way, your users know that you have new features or improvements available. Now, we need to store an access token. We can store access token directly in the code. That could be a potential security breach, especially if your repo is public. A safe method to use tokens is using secrets. To create a secret, go to Settings, find Secrets, Actions, and create a new repository secret. Here you can define the name and the value of your access token. In this case, I already created one called Access Token. Now it's time to automate the package publishing. Let's go to Actions, click on New Workflow, and set up a workflow yourself. We're going to use a default GitHub action and modify the values. First, change the name of the file and the name of the action. For example, publish release. Now we need to modify the triggers. Let's remove this and type release. That means this action will be triggered every time we create a new release. Now let's go to the jobs section. Here are the different tasks that will be run every time this trigger is activated. So here we need to remove these lines. We need to keep the uses. In this case, that means we're going to use the current GitHub space, that means our code. And now we're going to modify the node setup. Here I'm including two values. One to modify a specific version, so we can use the node version 16, and we're modifying the registry URL to point to GitHub registry. We're ready to compile our application. To do so, just include run npm CI that will compile our application using its dependencies, and finally run npm publish. This command will attempt to publish our package on GitHub registry, but it needs authentication. To authenticate, we need to include a new value. In this case, env to include environment variables and the value node auth token. Here we need to include the access token, but in this case we're going to use the secret to safely include it. To call the secret, just include $, curly braces, secret, and the value of my secret, in this case, access token. Let's save this file. And now we're going to run a release. A release means that your code is stable and ready to use for everyone. So to create a new release, find the release section, click on create a new release, select a tag. It's recommended to use the version that you're creating, for example, v1.1.6. Include a release title, for example, and here you can describe every feature and new improvement that you include in this new release. When you're ready, click on Publish Release. and our code will be compiled and ready in our repository. Let's go to code, and here you can see the release. If you click here, you can see the release notes, the version, and we also include a tag. Let's go to actions. Here, as you may notice, we're running an action. If we click here, we can see that we're compiling application and publish on GitHub. Now users can download the new version of your package. If you go here to code, select your package. Here you can see that the GitHub action just published your new version after your release. And this is how we solve this challenge. We now have an automated pipeline to release your code. GitHub has support to host multiple packages on the same repo. The GitHub registry can host different kinds of packages for technologies such as Node, Ruby, Docker, and many more. You can mix any combination of packages and technologies. Here, for example, in this repo, I have two different packages. The first one is for Node.js and JavaScript users, and the other one is based in Maven. This is a great option for projects focused on complex solutions. For example, this could be a library to optimize images. I can use the same algorithms to port different versions and make them available as packages for Ruby, Android, and Node using the same repo. And that's not all. The best part of hosting packages on GitHub is the visibility you have. Let me show you. Let's pretend we need software to read and process data from APIs, and let's search here in GitHub. When we search APIs inside GitHub, you can see that we can have millions of results, but not all of them are the same. Here, we can filter results to show only GitHub packages. And since GitHub supports many kinds of packages, we can also filter by type. For example, Ruby gems or Node packages. Millions of developers search every day on GitHub, and if your project is public, they can find and use your package. Combining the power of GitHub search and support for multiple platforms, developers can create multi-language software and access millions of potential users. When you work with packages, versioning is essential. This is how users know when a new version is released, what to expect when changes arrive, and even reduce conflicts by upgrading or downgrading versions. In your repo, there are a couple of places to keep track of your version. The first is the config files. Here I'm working on a Node package. Let's open package.json. And here we have the version value. As you can see, I have three different numbers here. That's because I'm using semantic versioning. Semantic versioning are common rules used by developers to reflect the scope of the changes. For example, if the changes in my package are only to fix bugs, to remove typos, but everything remains the same, it's possible to reflect that by changing the last number. For example, 6. It means that the changes are mostly patches and bug fixes. If the changes are minor, like new features or improvements, you should change the middle number. That means the software has changed, but everything is still compatible with other packages of the same major version. Now, the first number is the major version. You should change this when you introduce API changes or remove critical methods. A major version means changes could be incompatible with previous integrations. For more information about semantic versioning, you can check the official website on semver.org. Another place where the package versioning could be handy is on tags and releases. For example, here I am creating a new release, and I am able to choose a tag. Every time I release a stable version of my code, I also create a tag with the same version. For example, v1.1.5. This way, other developers can have a list with all the versions of my code to upgrade or downgrade. They also can use tags to track those changes on my Git history and retrieve snapshots of the previous version of my code to work on removed or changed features. Creating high-quality, business-ready software is hard and expensive. It takes hours of dedication, and software creators sometimes struggle to balance their day job with demanding code projects. In this lesson, we're going to explore options to monetize and make a popular package a reliable income source. The first option is to include ads and sponsor in your website in the README file. For example, here I have a package with a README file, and if I edit it, for example, include here a shout out to my sponsors. Every time someone tries to download my package, will be able to check out their links and images. This is a common technique used by many open source projects. Another option is to limit access to your repo and charge a fee to users. For example, if you go to Settings on your package repo and click on Collaborators, you can modify the repository visibility. For example, here, I'm going to change the visibility from public to private. From now on, only authorized people can access my package and code. So I can go to Collaborator and include people to access my packages. This way, I can charge a fee to them. If you have an organization account, you can also include additional privileges and permissions so they can access different parts of your code or different repositories. However, all these options are nothing but workarounds. Now we have a direct option to monetize your package using GitHub sponsors. This service allows sponsors to support your work, and even you can create supporters-only repositories and packages. Let's see an example on how a real-world project can use GitHub sponsors. Here, we're watching Babel, a popular project based on JavaScript. They have an option to support this project. If we click in here, we have an option to select different tiers to support this project, and we can do this monthly or just one time. In all cases, the funds will go to support this project and help them keep growing. With GitHub sponsors, software creators can focus in their projects and allocate more resources to improve their code. By default, GitHub includes basic analytics and information for your package usage. Here on the Packages section, you can find information on your number of users and downloads. However, if you're looking for more detailed tracking and analytics, you can use solutions like Google Analytics. This lesson, it's about how to install this tool on a GitHub page. First, go to your package repo and click on Settings. Select Pages, and here I can see the URL of a GitHub page I already created. Let's click here and open this page, where I have additional information for my package users. By default, GitHub assigns a basic template to display my page, and I cannot include additional scripts required to enable analytics. So let's create a custom template. Let's go back to GitHub click on Code, select Docs, and click on Add File, Create New File. Now we're gonna create a config file, name underscore config.yaml. Include here a property called layout with the value default. Click on Commit New File. And now you can create a custom template. So let's create it. Click again on Add File, Create New File. And here you can type underscore layouts slash default.html. This is a basic HTML file, so I have a code that we can start using. And this template works as an HTML wrapper. Please note that I have this property content here, and here is where my data is imported and displayed. Using this custom template, we have full access to import JavaScript files or a code snippet. Now it's time to get Google Analytics code. Let's go to Google Analytics. Make sure that you are on the admin zone. Select Data Streams. If you don't have stream already created, you can add one or select a current stream. Select Add New on Page tag and copy this snippet. Let's go back to our code. We can place this code on the head tag. So we can include it in here. And now we have everything we need to start tracking our users using Google Analytics. So save this code by clicking on Commit New File. Let's go back to our page, refresh, and now check out on Google Analytics. Make sure that you're using reports, and in this case, I'm checking on real time the users that are connected. In this case, since we have one user connected here, we can see that we are already tracking information. Using this custom template, you can support any other analytics software that you like. If your package involves more developers, you may need additional tools to collaborate, support, and foster a community around your project. GitHub has several tools to do that, and I want to show you a couple of open source projects using them. Let's start with GitHub Issues. Here, you can see how the community behind the React library use these issues. Issues are open for anyone with access to a repo. Here, users can report bugs, suggestions, or improvements. They can have replies from other developers and find possible solutions. GitHub Issues are great for managing communities. The next social feature I want to show you is pull requests. Here we are in another popular JavaScript library, Vue.js, and as you can see, their community used this feature to allow other developers to send new pieces of code, fix errors, and create new features. Everyone with access to your repo can fork and improve your package and use pull requests to send new features and improvements. Similar to issues, users can discuss and collaborate, but here the community can review code, request changes, and create concrete improvements. If the code owner and other reviewers agree, the changes can be merged securely with the base code, improving the package for everyone. GitHub has also wikis. Here we are in the Lottie project by Airbnb, an open source animation library. If you go to the wiki, we can find that they have already included documentation for several functionalities. Users with writing permissions can add or modify information. Finally, we have projects, where we can collaborate with other developers and plan roadmaps. Here I have a new project, and I can create new features assigned to specific users, and even use different views to track the progress of my project. By using all these features together, you can build and manage communities around your code. We reached the end of this course, and it's time to review what we learned and what is next. During this course, you learned that packages are niche software focused in a small part of logic for larger apps. To understand better your niche and users, take advantage of tools like GitHub Pages and Analytics. Be an expert on your code and your users. Create features that provide great value for them. Increase your footprint by porting and creating multiple versions of your package. You can distribute your packages in Ruby, Android, Docker, and Node using the same repo. GitHub Actions can go a long way. Learn more about its syntax and use it to automate tasks such as releases and testing. Don't forget to do your research. Read and compare software license for your package and find the one that is aligned with your project roadmap. Keep an eye to GitHub documentation. New features are added constantly, and you can take advantage of these new tools. Most of them are available even in the free tier accounts. And finally, remember that coding is better with more people. Use all the GitHub's social tools to collaborate, improve your package, and make solid communities.